So in our second unit, the next topic is Hurwitz criteria. Why we are going for this procedure? This criteria means we have to analyze the stability of the system. So there is a system, there is an input, and we will be any of the output. The ratio, the calculations of these two we have done in the form of transfer function. Up to that we know that. Okay. If there is feedback, we will be getting the H of us and what is the closed loop transfer function formula and all that there is basic closed loop transfer function formula is called G of us divided by 1 plus G of us H of us. So up to that we can see, and we have constructed root locus also on various methods. So root locus or what? If there is a only poles are there, how the system will be. Okay, there will be breakaway point. Okay, and we have to construct root locus. And after that, what we have discussed, if there is complex poles, how to calculate the stability, and if there is complex zeros, how to calculate the stability. All these things we have just see, and in the root locus itself, I have applied what Routh criteria for calculating the value of S. Okay. Now, based on that same procedure, we are going to study about the concept of stability for a control system. For a system to be controlled, what we are going to get? We are going to go for a controller that is a feedback, and with that, with the ratio of the output by input, we get a transfer function of transfer function formula, output to the ratio of input. That states what our stability. Okay. So one more method to achieve the or to analyze the stability of the system is Hurwitz criteria. So far we have known how to attain stability by using transfer function. We know that how to attain stability using root locus. We know that. Now the third method we are going to see the Hurwitz criteria. So on solving this, for our Hurwitz criteria, what we want the characteristics equation. So if the characteristics equation is given, how to solve this problem? That we are going to see there are four types of method that will be followed in Hurwitz criteria. Okay. So the first type, which is initially we have applied root locus. Okay. In root locus problem, I have applied this first type. In order to there are two methods to solve the value of S. I have told you that is replacing the S with J omega. That is one method. The characteristics between S will be there. We replace it with J omega, and we have substituted this J, we will be substituting it as minus J, and if it is A square, we will be substituting it as minus 1. Okay. So that is the method, one method. And the other method what we have gone for Routh calculus. The same thing is the first method. Okay. The question will be write it down. The characteristics equation of the system. The characteristics equation of the system given below. Characteristics equation of the system given below. Characteristic equation of the system given below. This is the equation which will be given in this is the problem based on what? The concept of stability analysis. Okay, question will be like this. The characteristic equation of the system given below. This is your system's characteristic equation. So determine how to determine what? Stability of the system. Determine the stability of the system. Okay. Determine the stability of the system. So, step number 1. First, what we have to do? First, we have to apply the Hurwitz criteria. Okay, that is Hurwitz array. We have to form that. Okay, that is apply Hurwitz criteria as how we are going to apply as Routh array. So, how will we forming the array? That is as S power 4, S cube, S square, S power 1, S power 0. Anything power 0 is 1, and that is our constant after S power 0. And in place of S power 4, what will be writing? Only even coefficients that we know. So, S power 1 and again plus 16. Okay, along with that, we will be will be writing the constant 5. And after that, S cube. For S cube, we will be writing what? The odd powers. That is 4. And then what it is? 10. There is no number over here, and there is missing term. We can say it as missing term. So we can name it as 0. So it is what? Missing term. This is the procedure to solve step by step. First, we have to write the array form. In S power 4, we have written the coefficient of odd as well as the constant. That is 1, S square coefficient 16, and then 5. And then S cube, that is odd, power of S which is odd, that is 4. After that, here S power 1 which is also odd, that is 10. After that, there is no term there, so it is a missing term, and that is marked as 0. Now what you have to do? You have to cross multiply. That is, we will multiply these two minus of these two, we will multiply. That is as 4 into 16 minus of 10 into 1 divided by 2, the term 4. Okay, and next one, what will be the same 4 multiplied as for the second term. This is for the first one. Okay, next for the second array, it is again we will be doing the first one. Okay, that is 4 into here the term is 5 minus what is here 0. 0 into what? The first 0 into 1. Okay. Everything we are doing with the reference of the first coefficients. Okay. So 4 into 5 minus of 0 into 1 divided by 2. The coefficient which you are taking as reference, that is 4. Okay. So on solving this, what will be getting? What is 4 into 16 minus 10 divided by 4? So we will be getting around what is the value? 13.5. Okay, the value is 13.5 over the third array. Okay, the next step over there 4 into 5 minus 15, that will be 0. So it becomes 20 by 4, that is 5. Over here the value is 5, and over here the value is 13.5. Next again, what we have to do for x power 1, we will be doing it in the same way. That is, we have to now take this 4 and 3.5 as the reference. Okay, the next two array. So we will be multiplying this 13.5 with what? So next term, that is 13.5 into 10. Where what is there? 10. 13.5 into 10 minus what is the next term here? 5 into the reference we will take it as 4. Okay, so that is 5 into the reference 4. So 5 into 4 divided by what is the first one we will take it as 13.5. This is the first term. What is the next term it will be? There is no term here, right? So it is written as a missing term as 0. Okay, on solving this one we will be getting 13.5 into 10 minus 5 into 4 divided by 13.5. What it is? 8.51 something, right? We will take it as 8.52. Here and next what is the term there? S power 0. S power 0 is what? Anything power 0. Here is the value of 1, right? Anything power 0 is 1. So it will be what? This 5. How will we determining the stability means you have to look out all the first term. What is the S power 4 coefficient first term? It is positive plus 1. What is the S cube coefficient first term? It is also positive plus 4. Next S square term, which is also positive, that is 13.5. Next S power 1 term, which is also positive, that is 8.52. Next S power 0, which is also positive, that is 5. How will we calculate this means? All the first element of the Routh criterion array, or else all the elements in the system. Okay, all the first element in the array as well as all the first element in the system is what? It's positive. There is no sign change. You have to describe it. It is all first element. Okay, all first element. Or if it is saying, if you are saying direct, it is saying in the number. That is one positive, negative, positive. Such sign changes are not there. Okay, there is no sign change. So how we are going to consider? Therefore, if everything the first element is positive means, therefore we will be considering that therefore the system is considered to be stable. Okay, this is how the conclusion we have to do. If the all the first element is positive, we will be saying that the element of the system is positive. There is no sign change. So we have concluded therefore the system is stable. We are clear about this. So now we are going to see a problem in type 2. State equation will be same like that. Okay. For the characteristics equations of the characteristics equation of the system given below as 4s power 4 plus 8s2 plus 2s square plus 10s plus 3 plus b equal to 0. Determine the stability of the system. Determine the stability of the system. Okay. First, let us we are going to apply Routh-Hurwitz criteria. So write it down. Apply Routh-Hurwitz criteria. As what basis? On Routh array basis. Okay. So what is how will be forming? S power 4 from the maximum power to the minimum. Okay. So that is S power 4 S cube. Again S square. S power 1. S power 0. In S power 4, what is the even coefficients as well as the constant? We will write it as 4, 2, 3. And for odd, it's all powers. It's powers. That is 8, 10. Here it is missing now. We have to take it as 0. Okay, what is the first step? We will take it as 8 into 2 minus of 10 into 2. We will be writing over the third element. That is 8 into 2 minus of 10 into 4 divided by the reference will take it as 8. So it is 8. Okay. So with the same reference we will be taking for the third also. That is 8 into 3 minus of 0 into 4 over there divided by with reference that is 8. Okay. So on solving this what will be getting?
Minus 3.
Minus 3. Okay. So here you have to be done. You are getting the value at negative. So we have to note that. Okay. It is minus 3. And what is the value there? It is 8. 3, right?
3.
If we have to multiply this 24 by 8, it is 3. So these two are the values for the S square. Okay. Next, S1 what you have to take these first element, that is 8 and minus 3. If you multiply minus 3 then what? 10 over there. That is minus 3 into 10. Minus of 2 is the 3 into the tab over the opposite. That is 3 into 8 divided by the reference is minus 3. The next number that is missing next, so it is considered to be 0. So when we solve this, what will be getting? We will be getting it as
18.
18. Okay. So it is plus 18.
Plus 18.
Okay. The sign should be mentioned. What is S? S over 0?
3.
The constant, that is 3. So if you look at the first term, how it is? So I'm looking after the. So if you have to write this statement, the first term of the Routh array is how it is?
Positive.
The first term of the Routh array has what it is? Has a
Negative.
negative sign over there. Okay, it has a what? Negative sign. So there is also what? There is also
Sign change.
sign 3 terms. Okay. Time 2 times, but we can say you should wait for 3 times. That is sign change is happening. That is from plus 8 to minus 3. Again from minus 3 to plus 8. In terms it is 3. And in times if you are saying it is how many times it is changing? It is changing for 2 times it is changing. From plus 8 to minus 3 again minus 3 to 18. Okay. So if this time changes happens means we have to calculate that the system is unstable. The system is unstable. That is the conclusion we have to do. Okay. So where the stable and unstable things will be applied means if in an electrical control system. Okay. If an electrical system is given, if you are going for a job or something else, on the electrical system you have to be observance of few means. What will happen? There will be an input and there will be an output, and as well as there will be a controls over there. Okay. If you then ask you to check the stability of the system. Okay, so what you have to do, you have to look after the first step is what? You have to look after the closed loop transfer function. Your system is the system's term is that is you will be taking it as the G of x. Okay, that is the system specification you will be taking it as the G of x. After that, you will be going to the feedback for what type of controller we are using. Okay, so we can use a proportional controller and if there will be I controller also we can use that. So that particular formula we have to know for the H of x. Okay, so from that what we understand, we will get the equations of closed loop transfer function. So you can solve that as a equation to form a characteristics equation. Now you can get the characteristics equation. On applying the Hurwitz criteria, you can say that the system is stable or unstable. Okay, so if a system, any electrical system is given to you, there is a controller. Take the system's system's value or system's prediction as G of x. The controller's prediction as H of x. Take this and close the transfer function, just substitute the values in the formula, and that is how your those outputs will be. Okay, this thing you will be applying in a system's performance. Okay, so in type 3, the characteristics system is given. You have to determine the stability, but the constant are not known, which means practically a system is there in your hand. What is the gain of that is not known. Okay, what is the output of that? Okay, it's not known by you. This K will say this what? K is what? K is gain, right? What does the gain be on from the particular system? It is not known for you. For that system, how will you calculate the stability? That is type 2. Okay, so if the gain is not known, all the wherever the gain applies, we will marking it as K. So applying the closed loop transfer function will be again the characteristic equation like this. Okay, now what you have to do? You have to apply Routh-Hurwitz criteria. Okay, this apply Routh-Hurwitz criteria as Routh-Hurwitz array. Okay, so take it as if the maximum power is 3. So it is as s power 3, s power 2, and s power 0. And since it is odd, we will be taking into the odd coefficient. That is as what is here 1, and what is the coefficient of s there? It is 7. Okay, and next for s square, what will be taking? We will be taking the
odd
3 alone, right? And there is no term over there, signal as 0. And for s, what will be calculated as? So since this k will be taking the k over here, constant as that is s cube s, and then what it is k. Okay, so we will be taking the k dot in the third term. Listen carefully. That is s cube. The we will be taking only the power constants as odd, right? So s cube 1 and s power 1 is 7. That's it. For s square, we will be taking the here. Okay, s power 0 is what? 0 is also even. So s power 2 and s power 0 even will be taking this. Okay, so what is the coefficient? 3, and here it is. Okay, clear by the taking that it is as s power 2. The coefficient is 3, and then s power 0. 0 is also here even. So the coefficient there is what is that? K. So we are taking k in the S square. Okay, so we have to solve this. That is 3 into 7 minus what is minus of what is here? K into 1 divided by who? Divided by 3. Next the term is 0. There won't be any term. What is S over 0? S over 0 the term is here. Constant gain K. Okay. So on solving the problem what will be getting? It is 21 minus K, right?
K by 7.
Just you can make it as this.
7 K.
21 minus K divided by 3.
3.
Now, what we have to say, for the system to be positive, for the system to be stable, the first element of the system should be positive. Okay, so we have, if it is positive, means we can say that the values must be greater than 0. 1 which is greater than 0. 3 which is also greater than 0, then this term should also be greater than 0. So we have to assume that for a system to be stable, we have to write here, for a system to be stable. What is the condition? For a system to be stable, it should be, the first term of the element should be positive. So to be positive, the system should be greater than, the element should be greater than 0. So according to that, we have what that is 21 minus K divided by 3 should be greater than 0. So when we take this 3 over K, it will become 21 minus K will be greater than 0. Okay, so if 21 minus K is greater than, what is K? Will be K will be less than 21. First case. The next case, K is what? The next S 0 is only K. The K should be also positive, which means the K should be greater than 0. So the K should be less than 21 and the K should be less than 0. We can write it like this. K is less than. Sorry. We can write like this. K is less than 0. Okay. And this greater than 0 and it's less than 21. In this particular limit, that is from 0 to 21, the system is stable. Okay, in 0 to 21, we will be getting that the first element of the system as positive. So we can conclude that the system is stable. Okay, how we can speak about that? We will be solving the same condition. Here the gain is not known. We have taken this K and we have substituted the same from the Hurwitz array over here, and we have assumed that for a system to be stable, the first element should be positive. If the system if the first element should be positive, what is the condition? It should be greater than 0. So we have achieved 21 minus K by 3, that should be greater than 0. So if we take the 3 over here, it will become what? 0. So we can say that 21 minus K is greater than 0. Then we can say that we know that K is less than how much? 21. Okay. So the next condition is the next term is K. So the K should also be here. If it is K greater than 0 means here this is also should be what? Greater than 0. Then only we can achieve that this is positive, right? So we have also taken that K is greater than 0. On seeing that both conditions, we have stated that 0 is less than K less than 21. So K should be in the limit of 0 to 21, that is which is positive. At that state only the system is stable. You can give the conclusion. When you get a system practically in your hand with the gain not known, you can say that when the system is stable, you can give a statement. Under this condition, from this value to this value, the system